A warm welcome to all to the lecture series in the course Mechanics of Solids. The course is being the next course for the prerequisite of engineering mechanics. So normally we deal with three mechanics. One is engineering mechanics, other one is fluid mechanics, other one is mechanics of solids. So what is the basic difference between these three mechanics? So mechanics is nothing but study of forces acting on a body, and engineering mechanics is a course which deals with study of deformation of rigid bodies, and fluid mechanics is the course that deals with um, mechanics of continuously deformable body, and fluid mechanics as well as the mechanics of solids. It deals with the deformation of solids, right? So, deformable bodies, we have to learn what is deformable body, and any other bodies are available for study. So, in the today's discussion, we'll have rigid bodies and deformable bodies. So, coming to rigid bodies and deformable bodies, this forms the foundation of solid mechanics. So let us see the picture on the right side. Yeah, nail is being hammered, and let us empathize this picture. What is the uh, strength of hammer? It should be more than nail or less than nail. Yes, it should be more than nail. Then only it is able to nail the nail. So, what is a rigid body? It is defined as the body with a negligible deformation under load, assumed perfectly stiff for simplified analysis in static and dynamics. So it enables forces, focus on forces, moments, and motion without considering the shape changes. So we have the real world example is the hammer under normal use where the deformation is minimal. When we hammer the nail, you don't see any deformation hammer. That is what it is being explained here. And coming to deformable body, you can see a picture car crumpling in a crash test demonstrating significant changes in form. So normally the front portion of the car is being subjected to crash test so that the passenger safety is ensured in every design. So a body that changes shape or size when subjected to external force and internal stresses and strains develop to resist this deformation. Critically in strength of materials and structural design. This is very, very important. This internal stresses and strains developed to resist this deformation. So mechanics of rigid bodies, core concepts, we have equilibrium forces and motion description, as well as simplified problems since there are few degrees of freedom leading to easier calculations, and it is foundational basics for classical statics and dynamic courses. And mechanics of deformable bodies, we have stress and strain, study of material response under the load, and we have constitutive relations, links between stress and strain that we call it as Hooke's law, that is within the elastic limit, the stress is directly proportional to strain. And we have the analysis scope includes deformation, deflection and failure modes. And finally, the design essentials crucial for safe, efficient structures and materials. So visualizing deformation, stress internal force per unit area resisting external loads. And the definition of strain is measure of deformation that is change in length to the original length. So elastic spring stretching and returning to its original length demonstrating Hookean behavior, which follows Hooke's law. Why both matter in engineering? Both rigid bodies and deformable bodies are very important since simplified powerful tool for many engineering problems, and it is crucial for understanding and material behavior and safety. So combined mastery enables innovation in design, analysis and material science. Here we have a small mind map to recollect or do a summary of this today's topic is we have learned something on rigid bodies and deformable bodies. That is the foundation of solid mechanics that goes into rigid body, deformable body, stress and strain, as well as engineering significance. It is very important to study the engineering significance of rigid body mechanics, deformable body mechanics, and combined mastery. So coming to the assessment part, here we have two questions in front of you to answer. It's a very simple question. A rigid body is defined as a body that cannot change its mass during motion and does not deform under applied forces, has zero moment of inertia, it's always fixed in space. And we learned that rigid body does not deform under applied forces. And a deformable body is the opposite side of the rigid body, which changes its shape or size when subjected to external force. Here are the references for this today's discussion. Thank you.